This is a lecture on a calculator using a one proportion z-test. I am just following through the two examples that I did in the previous lecture. You push stats over to tests. What you need is this number 5, the one proportion z-test. You push enter. Right at the top of the screen is the name of the test. The p sub 0, that's the null hypothesis. It's asking for what you put under your null hypothesis. The x is how many people said yes to your question. In a scenario of the abicity problem, we had a null hypothesis of 17%. 42 out of 200 replied yes to your question. The alternative hypothesis is a two-tailed test, so I will select and not equal to sign and then calculate. There is your z, test statistic, and a p-value that follows right after, and those are the two pieces of information that you need. If I go back to this test, no, wrong one. If I go back to this test, and instead of calculate, I will ask to draw. What it actually does, it actually draws out how big the tails are. And it shows you the p-value of 13% that's split up into two pieces of about 6% on each side. So if you find this picture convenient, calculator actually does it for you. I'm going to quit this menu, and do the next example on the lawyers who advertise. So statistics, over to test. You want the one proportion z-test. It's under 5, at least on my calculator. In this case, the null hypothesis is at 25%. And then 63% answered yes out of 200, except it's not a two-tailed test, it's a one-tailed test. So I need to push the right tail because that's what we're trying to prove. If you calculate, it'll give you the test statistic and the p-value. If you draw, you'll see that tail, the p-value, is all on the right side. So if you calculate, there is your just under 2% p-value and the test statistic. If you have any questions, let me know in class.